Hi viewers, let us see the program to toggle port P1.5 continuously with some delay. In last video, we have seen port 1 continuously with some delay for toggling. That is, we have taken only port 1 out of 4 ports in 8051 microcontroller. Port 0, port 1, port 2, port 3. Here, instead of this port 1, here P1.5 is chosen. That means only one bit of port 1 is continuously toggling is our concept. Compare with the previous problem. So let us see the explanation. So in last problem we have seen P1 which is equal to 0 x AA, and again we are using P1 which is equal to 0x55. That means, so port 1 is continuously toggling. That is, alternatively, the entire 8 bit of port 1 is on and off. So for AA, 10, 10, 10, 10 is the binary bits. So the lower nibble A is expanded with the binary value 1010, and higher nibble A is expanded with binary value 1010. Similarly, for this P1 is equal to 0x55, hexa value is replaced by binary value 0101, again 0101. So the lower nibble 5 and higher nibble 5 is written as it is in port 1 value. So this particular value are given as a input for toggling purpose, and the port 1 D naught, that is least significant bit, and higher significant bits are arranged in this manner, and continuously the entire 8 bits are continuously toggling. Similarly, the another P155 values are continuously toggling. That means on and off is continuously going on with the help of this P1 value, which is equal to 0xAA, and P1 is equal to 0x55. So instead of this particular concept, let us see the program to toggle port 1.5 continuously with some time delay. That means only fifth pin of port value is now toggling. So remaining values are assigned as a 0. So that means P1 which is equal to. So if we want to enable or disable this particular P1.5, out of this 8 bit, we have to enable or disable the D5 bit, that is the D0, D1, D2, D3, D4. So out of this D7, the D fifth place, D0, D1, D2, D3 and D4 bit is enable and disable. So at the time remaining values are assigned as 0. So let us write 0 and 0. Again third bit 0, 0. Now we have to take 0, 0, 0, 0. So when you give this entire 8 bits are 0, our port values is equal to 0. Now we have to assign P1.5 is equal to 1 and 0. So this is D naught, this bit is D1, this bit is D2, D3 and D4. Now this value is equal to 1, or this value will be equal to 0. So for one category, P1 is equal to 0, 0, 0, 1, 0, 0, 0, 0. For another category of port 1, all values are equal to 0. So simply we can write the 8 bit values are is equal to 0 for one port 1 8 bit value, and another port 1 value is equal to 0, 0, 0, 0, 1, 0, 0, 0, 0. So for this case, what is our value? We have to identify that D naught, because we have to enable or disable P1.5, P 1.0, 1.1, 1.2, 1.3, 1.4, 1.5. So 1.5 means this bit. So now this bit value is equal to 0, this bit value is equal to 1. So instead of this particular bit, you have to enable or disable this particular value. So for this case, the lower nibble and higher nibble values are, this value is equal to assigned as 0 for hexa value. Similarly, this 0010 assigned as 2. So in P1 equal to 0x20 and P1 is equal to 0x00 is the programming lines or source code for toggle the port P1.5 continuously with some delay. So this is concept behind this particular program. Now let us write this program and execute this program with the help of Kale software and Proteus software. Now we move to Kale software. So here we just go to project and create new project. So it will ask in which place you are going to create a new project. So I just give the project name example 3. So ex3, which is stored in the directory E. So ex3 is my project name. Now the project is created and here you have to select the atmel and C chips. You have to select atmel 89C51. So that particular chip is selected here and give press OK button and give yes. Now the project window is appear in this project area. Again you have to write the program now. So go to file and click new. In this area you can write the source code. So this is hash include register 51.h void main void, as it is what is the uh, lines we have included in previous program. The same concept is applied here. Only one small changes is going to done. So unsigned int x is taken here because here for x equal to 0, x less than 20,000, x plus plus. Likewise, the delay can be written in for loop and the parameter x variable is taken here. So unsigned int x is taken here. In last program, we put I here instead of this x. So whatever variable we want to use, that can be used here. So here for never ending loop is used and P1 is equal to 0x20. For loop is taken for this delay purpose and P1 is equal to 0x00. Again for loop is used for delay purpose and we just close the entire for loop and main program. This is our program for toggling the port 1.5. So now we have written the program, save this file. So in E drive, already I gave example 3 is our project name. So ex33.c. I just give the file name for source coding. So I save it here. So now you have to go for adding this project. So select target and right click it. Option for target is taken and you just change the crystal oscillator frequency as 12 megahertz and go to output. Enable this create hex file, then only the hex file for this project can be created with the help of the scale software. After that go to source group. Next select add existing file to group. So here ex33.c is appeared in this window. You just click it and add it. So automatically in our project ex3, the ex33.c file is added. So the embedded C program is now dumped into our project name ex3. Now the entire process for writing the program and adding into our project is over. Now once again save it and compile it. So for compilation we just press F7 or build this program. Now there are no errors in this program. So directly we move to Proteus now. So we can click it Proteus tool and we can go for new project. So it will ask some question. You just select it. So now you can go for pick device. So in this pick device, we can pick the device Atmal 89C51. So that is our microcontroller. We just take and place it in the schematic area. After that, we need only one LED. So here I just take LED. So one green LED, which is animated active LED, is chosen and place it in this area. So on right click it and rotate clockwise. The anode terminal of this LED is now connected with this port 1.5. It is port 1.5. So in case if the pin numbers are not visible clear, you can press zoom button, plus button. So now the P1.5 is connected in 6th pin. Take this line here and connect it here. Again go to terminal mode. Here the ground is there. Take this ground and place it in schematic area. Again connect this cathode terminal of LED with ground. Now the circuit diagram part which is in Proteus is over. Now we just double click it and dump our hex file into this Proteus. So go to E drive, because our programming is project also saved in E drive. So now go to object. In this our project name is ex3.hex. So that is selected here and press OK button. Now go to run. So continuously the LED is blinking. Continuously the LED is blinking. So if you want to change the time delay, so instead of the speed, you want to increase the speed or decrease the speed, you can stop the program and go to scale. So instead of this 20,000, if you give 40,000, automatically the time delay will be expanded. So you again save it and build this program. Once a compilation over, move to Proteus. Again, dump this program into Proteus. Click OK button and run this program. So it will take some time duration. So instead of this 10,000 value, now 40,000 is replaced. So the blinking of LED in Proteus is now slowly on and off. So this is the concept behind enabling or toggling the P1.5 port with some time delay duration instead of all 8 bits. So in last video we have seen all 8 bit of port 1 is continuously toggling with some time delay. Here we are using only 1 bit is continuously toggling with some time delay. I hope everyone understand this concept. You clearly capture and gather all the information about this Kale and Proteus tool. I hope everyone enjoyed this video. So kindly see my video. If you have any doubts, you can give some comments in this video. Thank you all. Kindly subscribe my video. Continuously watch my channel. Thank you all.